In this video we'll be taking a look at the logger challenge on HackTheBox. So it's an easy forensics challenge, and the description says a client reported that a PC might have been affected as it's running slow. We've collected all evidence from the suspect workstation and found a suspicious trace of USB traffic. Can you identify the compromised data? So presumably we're going to get a packet capture here that we can analyze. So let's open up the archive and let's copy keystroke.pcap.ng over to our local directory, and we'll just, as usual, do our basic file checks here. So we'll just verify the file type is keystrokes, which it is. Let's open it up in Wireshark, and you can see, is it all USB traffic here? Let's have a look at the go to statistics. We can capture the file properties first of all. See there's 408 packets, and we can, well, what was the length of the packet capture was 55 seconds, and we can see the date that it was captured on. Let's have a look at the protocol hierarchy, and we'll see that it's all USB, and 18.9% of that are text items. Let's select that. Select those. Can we do a follow? No, we can't follow anything here. So we have these text items. With this, each time it has a setup data, or not each time actually. Alright, we have some different values here. I don't really know what any of that means to us. Let's close that and just have a scroll through. Okay. So we have our HID data in some of these 200300. So presumably some of these contain data and some contain operations like opcodes. Let's minimize this and take a look on Google. We'll say USB keystroke pcap. What do we have? USB keyboard pcap analysis. Sounds good. Let's take a look at this. And this article doesn't really actually give us too much here. It says that if you have a pcap of a USB connection with lots of interruptions, it's probably a USB keyboard connection. Do we have a lot of interruptions yet? A lot of these interrupt in. Wireshark filter. This Wireshark filter could be useful. Let's try that. It could be important to know that the data starts with 02. Is pressed using shift. Okay, that could be interesting as well. So we'll maybe need to know whether sometimes it's capitals or special characters because shift's being used. So we'll select this filter, and what did that filter out much? Yeah, okay, started at 49 now. But I still need to be able to read this somehow. So you have more information, find some scripts on how to analyze this in, and then there's two links here. Let's take a look. So we have one which is a write-up from a 2018 CTF. And they're going through here noting that one, the source and destination is using two-way communication. Two, the protocol is USB. Alright, probably like we have here as well. Let's go back to our source and destination. I'm not seeing two-way there, but it might be because we've got that filter on. Yeah, okay, so we've got two-way. It's just because I enabled that filter, it's now only giving us one way. That's fine. Let's see what else they mention here. Okay, they found this link which came in handy to understand the frame and a few details of the data input. Alright, looks like that's going to be overkill probably for what we need here. Let's keep going. Where's the TLDR? Alright, so if you want to really understand what's going on here, this is probably going to be a good way to do it. It looks like they're telling us here that this filter is the same here, so we've got down to the same point, and if we use that filter and then export the data as CSV to get the column, okay, and then cut, okay, and then they have this Python map as well. Okay, should we try it? Let's give it a go. So they use this filter, which we're using as well. And then let's file export. Do we need to select these? File export specified packets. and selected packets only, and let's say that the file name is, I want to export it to CSV. Export as CSV. Oh, we don't have a CSV. What are they actually extracting here? Exporting the data. Okay, it looks like they're just taking the leftover data capture here, is it? Let's add the capture data to column, and then it looks like they're exporting the full data to get the column, but it's only the leftover data capture that they're trying to use by the looks of it. So let's just cancel this. Cancel that export. We're doing the filter already. Where is our leftover data capture? Is it just the HID? Let's apply as a column HID data. Presumably this is the leftover data capture that they're talking about. It looks quite similar anyway, so I'm going to say it is. So let's go back and let's select these. Let's export as CSV and just call this data, save that, and let's see what that looks like. Data.csv. Alright, yeah, it looks good. Let's close that, and they then use this. Alright, we need to change this a bit because theirs is called leftover data capture and ours is not. So let's have a look what our command is going to be. We're catting data.csv, and we're going to cut out, oh, the quotes are messed up as well. I hate this so much. Alright, let's do it. Let's go and change every quote individually. Why not? Alright, so leftover data capture. Ours is called HID data. Let's paste that there. This is our command. Let's see if it works. Paste that in. Doesn't work because of the way we've got our quotes here. What did they? Just kinda, I guess, try that. Cat data cut dash D. So in their example, they have two quotes around the backslash. Oh, I guess they're escaping this quote. Let's go back to our command then. And they're escaping this quote. Try that. Alright, let's open up hex output. Okay, so we've extracted our HID data. That's looking better. What's the next step? The next step is to use this script to map the data. Alright, let's do that. We have a Python script here. Oh, we're going to have to go and change all the quotes, aren't we? This is going to be annoying. Okay. Is there an option to view this as like raw? No. Oh, why do people not use normal quotes on their blogs? Alright, let's do codium new.py. Let's paste this in here, and we're gonna say replace all of these with a normal quote. Replace all, And also, can you please replace all of these with a normal quote? Replace all. Alright. And here it opens hex output, which we already have. That's cool. And then it's going to print this out. It's going to be in Python 2, so let's make sure we do that in Python 2. We clear some of this from the screen. Python 2, new.py, and we get an error about no encoding. Let's open that again. No encoding for what? Sorry, what was the on line 53? Oh, it's this quote here. Any more single quotes I need to worry about? No, I don't think so. Let's try it. Oops, wrong button. Python, okay. Okay, now we're going to have indentation problems. Alright. Codium. Let's try and format this. Let's just double check that there's no... that they don't have a... Is there a GitHub or anything to this? Because... seems pretty crazy. Let's have a look. Ali... Fawazir... GitHub... No, alright, don't see anything. Ali, if you ever watch this video, please, if you're going to supply code, supply it in a way that people can actually adapt it without basically rewriting it themselves. Okay, so we open my keys, we set I to 1, and then for line in my keys, we're going to do this byte array. We're going to set bytes array is equal to, I'm going to strip the line, and then for byte, so we need this to be part of this loop. Then we're going to say if the byte is equal to, alright, so there we go. Keyval, so keyval is, so this is all one loop. I'm going to say if keyval is in the new map, we're going to print, else we're going to print that, and then we're going to increment the loop counter. Alright, that looks good to me. Let's see if we've done that properly. Let's do Python 2 new.py. We get this error saying an encoding wasn't declared on line 63. Line 63, which is this comment. Let's take that out. I bet we're going to get an error here as well. No, we don't. Okay, nice. Oh, and this looks good. HTB, and then we have 33, etc. You can see caps lock is getting enabled, so we might need to work out. Let's go back to our thing here, and then okay, print format. It's interesting that they had that commented out, and then we have the flag at the end. So where is the print actually done? Right here, so let's print this and let's say end. Will that get rid of the... Is that because it's not Python 3? I guess so. Okay, let's say final equals, in a quote, and we'll say, instead of printing, we'll do final plus equals, and then at the end we'll print out final. Let's run that again. Okay, that's looking better. The issue here is we have the caps lock here, but we can see HTB. It's not all looking great. There's still quite a lot missing. Alright, let's clear this. We could try and work out what's going wrong here. What I might do is have a look at another, see if there's any more tools, because it seems like this is quite quickly thrown together just to solve this challenge. I'd imagine that we can actually find a better a better tool on GitHub to automate the process for us. So let's look into that. Let's search for GitHub keyboard USB parser, and we've got a couple here. We've got this one CTF USB keyboard parser, and we also have this one USB keyboard parser. So let's have a look at these and see what they do. Let's begin with the CTF USB keyboard parser. It says this is an updated script from this CTF challenge. Let's see if it looks similar to ours. It does look similar by the looks of it so far. Okay. We have the when I finish CTF, I end up doing a script. Okay, so they've basically mapped up the key codes there. There's a script, and it gives a few suggestions, and one of them had the flag. Alright, so let's try and grab this. Let's clone the repo. And let's see how to run it. So we just pass in Python USB keyboard.py, and then we pass in a file. What's the file though? It doesn't actually describe how to extract file from pcap. Might not work for every pcap. Okay. Should we try this? Let's paste this in, and we want to change this to our pcap name, which is keystrokes. If we run that, we get nothing at all. Okay, what were we missing there? Okay, let's see. It's suggested here some versions of Wireshark don't add, so let's try this as well. Some versions of T-Shark, sorry. So we'll pass that in. We'll give it the correct pcap name. Keystrokes, run that, and then it didn't write that to file, but I guess it would have printed the display anyway, so let's not worry about that. Not looking good for us. If this happens, it didn't happen for us, so let's see, what about the file that we extracted? Because that had I think that had like the data we needed in it. So let's cat out hex output. Hopefully this has what we need in it. Let's run Python CTF USB keyboard parser and USB keyboard. Missing a file. Does it just take in the file? Hopefully. Let's put in hex output. Index is out of range. Okay. What about the data CSV? Invalid literal. Python 2, is that gonna help us? No. Okay. What about this other keyboard parser that we have here? This one just actually takes a pcap. That would be really handy. Let's grab this. And we'll git clone. We'll do Python USB keyboard parser, and then let's see if it gives us. Oh, it doesn't even give us a help option there. Okay, so it just takes in the pcap as well. So let's run that again. Pass in keystrokes. Unknown key combination didn't work for us. Okay. Okay, let's return to our CTF USB keyboard parser then. So whenever we tried to run these examples, these didn't work for us, and we were using the we were selecting this USB cap data, but we don't actually have that in. You'll notice that in the guides that we went through, they have they're using this leftover cap data, whereas we've been looking at the HID data here. If you see down here, HID data, if we right click that and go to apply as filter, you can see it's USB HID.data rather than the example that we have of USB.cap data. So let's try and paste that in and see if we can change the fields. Let's say USB HID.data. Presumably we need to do that here as well. HID, sorry, USB HID.data. Oh, we need to put in the correct. I think that USB data length is going to be an issue as well, but let's just try this for now. Keystrokes. Alright, that looked a bit better, didn't it? It cut out the, but it looks like it's just cut out. Let's try and do diff hex output and USB pcap data. So I think these are the same, have produced the same results. Once it's got our data for us, USB cap data, and then they're just passing that in as a file. So Python CTF USB keyboard parser, USB keyboard, and then USB pcap data. But that doesn't work for us. Interesting. Okay. I actually solved this challenge a while ago, and I'm pretty sure I used this tool to do it. So I'm not too sure what I'm missing this time around. But I have another write up here from another similar CTF with another script on it. It's also using the cap data, so we might have similar problems, but let's try it anyway. This is specifically focusing on the mixed case, which is obviously the issue for us as well. We were able to retrieve the HTB part of the flag, but due to the caps lock and stuff, it just wasn't as easy to determine the full flag. So they've given us a script here to try. Let's go and let's view the raw. Let's grab a copy of it, and we'll do. I'm going to replace our new.py actually because wasn't helping us much at all. Save that, and the use case is it's going to take in a file name. Alright, so if we do Python new.py and we want to pass in, presumably this is looking to take in the USB pcap data as well rather than the pcap. Yep, USB flag they've taken. Okay. So pass in USB pcap data, and okay, we've got a similar we've got the similar result to in our other tool there. That's interesting because they don't have that. We'll detect. Alright, so it's focusing on shifted keys, I guess here. In this case, shift key caps lock was used rather than shift key. Let me open this up and just open a new file, zoom in on this, and we have caps lock. We know HackTheBox is in caps lock anyway, so HTB, caps lock is turned off now, so we have I, caps lock is then turned on, so we have C, N, we have 533, which is just hex, is just leet for C, and then we have our caps lock is turned off, so Y is lowercase. We have our caps lock is turned on, so this is uppercase. We have our caps lock is turned off, and then we have our caps lock is turned on again, so this is back up to uppercase, and we have finally our caps lock is turned off again. So there's the flag. We could have just done that manually from the beginning. To be honest with you, I just kind of wanted to. I'm pretty sure whenever I originally solved this challenge, I used a tool that actually just printed out the flag. So maybe there's other examples on GitHub. What I'm going to do is I'll provide links to all of these in the description, and then you can work through maybe adapt the scripts as well. So it's probably just be a case of updating this. Well, they do have the caps lock here. Yeah, it'd be cool if caps lock could be used to actually determine. I suppose the problem is you might not know, the system wouldn't really know whether caps lock was on to begin with, so it'd have to give you two alternative solutions as well. It would have to give you one that has HTB in capitals and one that has HTB, basically a reverse of this. It would also have to give you like HackTheBox capital I underscore and then lowercase, etc. But that's been the logger challenge anyway. I hope you've enjoyed this video. If you have any questions or comments, you can leave them down below. As I say, if you solve this challenge any differently or got any cool tips or tricks, let me know. Thanks, bye.